Hello everybody, welcome to part 6 of the Openthread 101 series, and in this video I will show you how to sniff Openthread traffic with Wireshark. So Wireshark is a network packet inspection tool. So basically it allows you to take a deep look into a network packet, and help you understand the underlying protocols. Wireshark is a very well-known tool, and for normal networks like Ethernet or LAN network, you can just use it on your PC. But in our case, for Openthread, we would need to make some additional steps to be able to sniff network traffic. And the goal is to sniff packets that are let's say that are for network configuration. So our nodes in the thread network, since thread network is a mesh network, they exchange different types of information with each other, and we would be able to see those packets, and we would also be able to see packets that are generated by us as a user. This will help us learn and understand Openthread a bit more in detail, and in upcoming videos we can then go a bit more into details about how a network is formed, or different actions that the leader takes, or things like that. So the requirements for this is, in our case, we would need NRF52840 dongle and Wireshark application installed on our PC. So Wireshark, by default, it is not able to sniff Openthread. So Wireshark is just a packet inspection tool. It is not a packet capture tool. It is not packet capturing. But what it does is, if you have some packet captured, then you can open them in Wireshark, and Wireshark will let you have a look at them in a more user-friendly way. And for capturing, we would use the NRF52840 dongle. So what we would do is we would flash a sniffer firmware into our dongle, and that dongle would then be connected with our PC via a USB port, and then we would install an extension in Wireshark. Using that extension, Wireshark would be able to get the packets from the dongle and show it to us in real time. So let's get started. So to get started, the sniffer firmware is hosted by Nordic Semiconductor here, and there is a patched version of it because in the Wireshark extension there is a bug which is not fixed in the official repository, so we would use the patched version. But let's go to this repository and I will show you what I mean. So this is the repository for NRF sniffer for 802.15.4, and inside here you have the hex files, which are the firmware for the dongle. Here the firmware for the NRF52840 development kit is here, and also the firmware for NRF5340 development kit. We would use the firmware for the dongle, and then here you have the Wireshark extensions. In our case, we would use the Python version of these extensions. But since I have been using this, and I know that there is a bug, it's a small bug, but it's just an inconvenience, so we would use the version which is fixed. So here, if you go to the pull request, there is already a fix for this. So this is basically in Wireshark, when you stop the sniffing, it does not stop and make the things freeze, and then you cannot use it. So you have to either restart or close and open Wireshark again, and there's a pull request for it that fixes that issue. And basically that is the pull request. You can have a look at this in detail, but for us we will just use it. So we would go to the repository where the pull request is coming from, and we would clone that repository. So let's go to desktop, and we would do git clone and then this repository. So now this repository has been cloned. Let's exit from here, because the next steps that we have to do are documented by Nordic Semiconductors in their guide. So the Nordic Semiconductor has a guide, NRF sniffer 802.15.4, and the link to that can be found in the GitHub repository as well. And inside here, what we want is first install the NRF sniffer. So to install the sniffer or configuring, we would have to flash the dongle, and to flash the dongle we would need software from Nordic called NRF programmer, and well, I'll show you how to get it. So we would get NRF. First we would need to get this application, NRF Connect for desktop. So we would download it for our system, which is Linux, and it's an app image. So let's download it also into desktop. Once it is downloaded, we go to desktop, do ls, and if you do ll, it is not marked as executable. So what we do is we would mark it as executable so that we can execute it. And let's just run it from here. So we can run it from here as well. You can right click on it and click run as well. You would just run it from here. So we have, this is the NRF Connect for desktop application, and what we need is this tool called Programmer. So we would install it. So it is ready now. There is some error, but we would just ignore it for now. It says something about the Segar J-Link version, but for now let's just ignore it. So we would open the Programmer now, and now I will plug in the dongle, and once the dongle is plugged in, I will check for the devices here in this programmer. So now the dongle has been plugged in. Let's have a look at this. So here you see that it shows one device, NRF 802.15.4 sniffer. It's because this dongle has been flashed with the sniffer firmware from before, from the last tests run when I was doing it, and we would not be able to flash it like this because currently this dongle is running the application. And so in order to flash this, we would have to boot the dongle in bootloader mode, which is then enable us to flash it. So let's have a look. First, when I click it like this, you can add a file as well. So the file is here, dongle hex, but you see it is not, we're not able to write here because this is just it's running an application, and that application does not allow us to write anything there. So we would have to boot the dongle in the bootloader mode, and then that would enable us to write the firmware here. The dongle does not come with the debugger or the J-Link debugger, so in order to flash this, they provide a bootloader which enables us to write the application in there. I will show you, but let's change the dongle into bootloader mode. In order to do that, you have to press the button which is next to the white button. I will add the picture here also to show you, but that button is a bit in an inconvenient location, but I guess it is what it is. So I would press that button. So currently the dongle is blinking green, so I would press that button and then it should start blinking red. So now the dongle is blinking red and our selected device has disappeared, but now our device name is OpenDFU bootloader. So if you open it, it will read the memory space of this device. And if we look here, now we have something called master boot record, and then we have an application here, and here we have the bootloader. So what happens when the dongle boots, it goes to the master boot record, and then in the bootloader it goes into the master boot record, and the bootloader are then responsible for running the application. And if you press the button, then they also go into the DFU mode. So basically they are waiting for you to send them the application, and they will then write the application in the appropriate memory location. So currently it's in the DFU mode. So we would add our file here. So that's a hex file for dongle, and then we say write. So it should start writing the firmware to the dongle. So now the dongle has been flashed and it is blinking green again. That means it's in operation now. So we would close out of here. We can exit from here and exit from here as well. Now that the sniffer has been flashed, we would have to install Wireshark on our system. And I know that Ubuntu provides an up-to-date version of Wireshark in their official repositories. So we would have to do, all we would have to do is to sudo apt install Wireshark and enter our password, and this would then install the applications. For me, I had installed it before, and some of the dependencies were already installed, so it took shorter. And but for you, maybe it would install a bit more packages. So Wireshark has been installed. We can exit out of here. We don't have to do this user stuff because since I installed it from the official distributions, they already have done some of this stuff. So we don't have to do this. So now that Wireshark has been installed, we would need to do two things. So one is configuration of Wireshark so that it can read 802.15.4 packets, and we would have to also install the extension that we have, because without that extension Wireshark would not be able to talk with the dongle. So that extension is used by Wireshark to talk with the dongle and read packets from there, and then it will show it to us. So first let's go through this extension installation, and then we would do the configuration later. The configuration is for decrypting and decompressing Openthread packets, because as you know, those are 802.15.4 packets, and those are encrypted and also compressed by 6LoWPAN. So let's go to the extension installation. So we would go to the, or it's also called a plugin. So we would install our plugin here. So first of all, the dependency is we would need to install PySerial on our system. I probably already have done this, but this is how you do this. So this should be installed on the Python of your system. It is already installed, so we don't have to do this. And then I open Wireshark, then go to help, about Wireshark. Inside the folders we would have to install the xcap plugin or xcap extension. So there are two paths. One is the global one is the personal one. I would do it in the personal one. So I've opened this directory here, and then open desktop in another tab, go to sniffer, this sniffer, copy this file, close this tab, and paste this file here, so that this is the file, the place where Wireshark would be able to find this sniffer. And this is, remember, the patched version, so it should be working as we expect. So now here, if you look, we don't see any interface for IEEE 802.15.4 because we haven't refreshed our interfaces yet. Now if we refresh the interfaces, we see that there is one new one, NRF sniffer for 802.15.4, and there is one more step. So if you click on the gear icon here, you can set which channel do you want to listen to. And in our case, the channel that our network uses is 14, I believe. So we would just set that to channel 15, and then we can double click here to start capturing. So now we are capturing, but we don't see anything because none of our device is online. So let's open Visual Studio Code so that we can connect our Openthread devices. So if you see now, there is no device connected. So I will turn on one board, and now you see device 2 has been turned on. So we would go to the serial port of this device. So now we are connected with it. Let's bring it to a newer window so that we can see both of them at the same time. So here now you see that still nothing is connected, and if we check, I will increase the size a bit, OT state here, it is disabled. And if we check the active data set, we see that it is also available, so it is being set. So all we need to do is to bring up the interface, OT ifconfig up, and then OT thread start. Both of these steps we can also configure in the firmware to have them done by device start, but in the default firmware that Nordic provides, it is not done. So the default examples for the CLI, so it is not done, so we will just go with it, and I think it's fine this way, so that we can control when we want to bring our devices online. So when I press enter here, you should see some traffic being generated, and those traffic would be some of this we would be able to see, or but most of it would be you would not be able to understand it. Let's see. So now this device FE80 is sending a broadcast message to FF02. So that is, I guess, the broadcast address for all the routers. Okay, so now that Wireshark capturing is functioning, we will stop this video here, and we will continue in the next one, where we will configure Wireshark so that we can then observe the encrypted traffic, and we will configure also it so that we can then decompress some of the compressions. So I hope this video was useful, and see you in the next one. Thank you very much for watching.